Okay, we're gonna go ahead and get started on the session and roll things out, but welcome to the session, GIS for everyone. So enabling spatial thinking using your campus license to ArcGIS, and given the audience here, we'll probably rotate some things up. And so if you have questions at any point during this next hour and a half, by all means, it's not meant to be sort of a directional presentation, but rather interactive. So conversations, and you'll hear us sort of jump in on one another, so at any point interrupt. And it should be a good hour and a half. So my name is Amy Work. I am a GIS librarian at UC San Diego. I have about 15 years of experience doing GIS work and more than 8 years within higher education institutions across the US. And I have my colleagues here.
So I'm Carlos Barahona. I'm a systems architect with UC Davis. I specifically work for environmental science and policy, which is part of the College of Agriculture and Environmental Sciences. But that is to say that my background is primarily in IT, basically systems administration. But my position currently, I'm actually at 25% still. I started at 100, but 25% still in research. So my background there, working with the Center for Environmental Policy and Behavior, is largely in collective decision making, largely around social network analysis for policy networks.
I'm Michael Stewart, UC San Diego. I work at the library as an IT manager, and I have the pleasure of building out geospatial services with one hat that I wear for Amy and our larger community. So we'd like to know a little bit about who you are and what you're doing with GIS, and maybe why you showed up today or what you think is possible. We've all found it's actually really interesting to connect with each other and ask, what do you know about GIS? How's it been used at your campus, and why might you be excited about it? And what do you think your role might be eventually? Or how would you like to see yourself involved? We have a lot of different roles. I think I can see in the audience. We have definitely library, we have academic units, we have some developers in the audience, and it's just kind of cool to kind of catch up with that. So why don't we take 3 minutes, kind of catch up with each other, don't cheat, talk to someone from a different institution.
So
yes, you have to get up and move. This is part of this.
So I'm professional, but I'm also a developer here. In the library, I work with John in the library, and I work not much in GIS so far. I've done the projects with John, air photo points, more space science framework that I would like to learn more about.
So I don't actually do much of that, but it's more of a personal for me. So I didn't realize the session went so it's like, oh, moderately my little brother geocache. Specialization. I know it's around.
So you just want to know your brother.
Global policy strategy.
Yeah, this guy don't get that. I'm not here.
I was down at
So I know there's awesome departments in San Diego.
there's a lot of departments. I just have your hands. They're free. You like a free field. She's just wandering the eye. I do feel that. And I draw that, but my apps are I actually divided it on the computer lab.
It is.
How's the Amy in the library? She's old.
Yeah, so excellent.
That's awesome. That's awesome.
Scott, what do you do next?
I'm the next GIS librarian. I run
Oh, okay, so I think our is definitely our.
She's just been, right with the open house.
So cool.
Seen that, right? Yeah. We've got some crimson hexagon, common elements. So how involved are you guys?
Actually, I
I
did
did
a
a little this development. So are you the owner? Are you the owner? Are you the manager?
I'm a product
You're a product owner?
building like online game. Like data about social interactions and changing parameters in those games. Like, and
Michael.
behavior. Really, if we have these social things like psychology, like prisoners dilemma. Okay, but we have
No.
or the facilities associated with somebody. That's basically within the game.
I go into this. It's hard to shut down.
There's a change over. That's, I got no idea. So that's just great meeting a little bit of you. We have this great little survey 1, 2, 3 that was actually just a little bit of data collection for us, but we're kind of curious what the idea of a GIS for everyone geospatial campus means to you, and what's your background knowledge of how that works at your own campus. So if you want to like start this, feel free to do it or not, but we'll have a quick demonstration on like what that data meant at the end of the session.
And so how many of you are familiar with GIS? How many of you use it on a semi-regular basis? Sort of maybe once a year basis, maybe never?
Google
Okay.
Maps count?
Yes.
It is a system, yeah.
If that's part of your job.
Yeah.
Yes.
Oh, no.
Yeah. It is, and Google Maps is sort of an entry point where you can sort of pull in information. It's limited in sort of its analytics, but then if you pull in the Earth Engine, then you can do more stuff with it. So GIS can be any platform. It's really dealing with data that is, it's a technology that enables data discovery with multivariate data, analysis, and sort of a deeper level, it provides us a deeper level of understanding of the information that we're working with. GIS deals with any data that has a location component to it. So that can be a latitude, longitude, that can be an address, that can be something tied to a state or county boundary. So there's things in our world that all have location components, and it's a matter of analyzing that using a GIS system. And so as we go through some of this today, why do we even use a GIS system? And we're really starting to think about geographic reasoning and spatial thinking. So you do spatial thinking every day of your life. When you get up in the morning, if you pack your car, if you put your groceries in your car, if you mow the lawn, you're doing some sort of spatial thinking to analyze the quickest route to sort of be done with the task or how to fit everything in. And so one of the first rules of the laws of geography by Tobler is that near things are related. Almost everything's related, but near things are more related than distant. And so how do we examine that using a GIS system? And so as we start to explore some of them, right? If we look at population density, there are patterns in population. There are patterns in certain components of elevation are more related so than others. And if we didn't have this spatial correlation or this representation, some of our population distribution or elevation would just look like a big cluster. And so there's patterns to this, and we can use these technologies to have a better understanding and start to ask questions of things that we normally might not think about or that we want to explore in greater detail.
Well, just so you know, Lowell Tobler was a professor
He
here.
was. He passed away
He passed away just last year.
Yeah.
Yeah, really nice guy.
Like
Yeah,
really well known in terms of the world of
Very well.
geography. And I wrote it down and I couldn't find my note, but someone said they asked him like, now that, because this was all developed for GIS.
Yeah.
And so a matter of what does GIS, now that we use GIS, how would we change it? And it was things that like, things that are geospatially located are more related to other things or like in proximity, but you would modify this initial law. Yeah, I would have loved to have been in that. But so some of the basic concepts that we can cover with geospatial thinking and geographic reasoning are mapping where things are, right? Google Maps can help us to do that. We can take a look at mapping the most and least. So where do you have, for example, voting? Where are people voting? Mapping density, finding what's inside. So how many, let's take a look at how many school districts are inside of a zip code, right? And so looking at tax initiatives and things like that, finding what's nearby, mapping change over time. So we can take a look from 1900 to present day or 1990 to present day. But then we can start to get into some more advanced concepts, finding suitable locations. If you're a vineyard owner, where are you going to site your next vineyard? If you're looking at opening a ski slope, what are the slopes on what side of the mountains would be most suitable for building a ski slope and then actually making a revenue off of that? Rating suitable locations. So if you're a business owner and you're going through and you want to open up a new, let's say, a new independent coffee shop, right? Where are you going to go? Where are the coffee shops located? What's your market? And you can do all of that within GIS. Modeling paths, shipping, tracking. There was a recent article about using satellite imagery to track the progress of luxury cars from Russia to I think it was the Koreas. And so it's a matter of you turned off the tracking beacon so that those cars don't get stolen. And so you can start to leverage these technologies to do all of this and interaction as well. So Carlos, I think you have some interesting projects at UC Davis that sort of highlight some of these technologies.
Yeah, so I chose to highlight one of UC Davis's groups. It's the Center for Regional Change. This is actually a group that I used to work with in my previous life in human ecology, but they did a project called Putting Youth on the Map. The project is really around building this web application that promotes the well-being of access to public information. Really, this is like statistical information that has to do with equity and opportunity for younger generations. This was built as a tool that young people can access easily and get that information so that they can then go to their leaders and hold them, the decision makers, accountable, and really so that we can look at this and find ways to improve their opportunities. Mainly I chose to highlight this because it was the Sauder Award winner for 2017. So we just saw the Sauder Awards earlier today. 2 years ago, this was our project. And if you want to go check that out, there's a lot of information in there. And they actually created what they called an opportunity index.
And so another interesting project at UC San Diego is the Wildfire Project. Has anyone heard of this project?
Yeah.
So what do you know about the Wildfire Project?
So is this the researcher with the hard name to pronounce?
Jessica Block or Ilke?
Ilke.
Yes.
I saw Ilke present on this project with the drone work, and she showed some really cool flyovers. She presented for the research expo.
Yeah. So wildfire is a matter of like you have wildfires that are rapidly advancing. How do you factor in real-time climate, real-time weather data with wind speeds, with current sort of vegetation cover, which is fuel for wildfires, and then of understanding where wildfires happened in the past, what's the vegetation load presently versus sort of the hydrology and all those. So they pulled all of this into a single GIS system to be able to sort of better model where wildfires are going to happen, so the rate and the direction of spread, but then also be able to assist first responders to be able to sort of either evacuate homes in a better timely manner or respond to situations where the fire has spread. And so it's out of the San Diego Supercomputer Center, but I think they said without even sharing this link, all of a sudden when some of the wildfires were happening last year, they had thousands of hits on the link just because people were leveraging that is sort of general population information, not necessarily for research and just for first responders.
Oh, just as an aside, I know the first time that I saw this was UC Davis. We're in a very fire-prone region. We actually had our campus shut down for smoke hazards for a little over a week last year, and that's never seen before. But during that same thing, we had our campus-wide Slack. This was one of the, we're both looking at this for like if we needed to evacuate, but this and a couple other sites for smoke analysis, so basically where we thought the smoke was going to go.
And then in addition to that, I mean, John, you were at the plenary last week, so you saw this, but they're mapping those biodiversity hotspots from NatureServe. And so this concept of being able to identify those risks or the areas that are most critical, biodiversity loss, where species are found, and that's dealing with sort of research data, but then there's also another side of crowdsourced information and being able to better support those models of you see a salamander or a frog in a specific area, and then you have a neighboring area that's not necessarily, that species isn't found. How does that help play into development or being able to better handle sort of risks that might increase or the sort of loss of biodiversity? And so this ended up pulling in over 2,600 detailed species habitat records, so the first of its kind. And so being able to launch that and enable researchers and others to have access to that information. And so as we're dealing with this, all of these are dealing with data. We said these data have location, which makes them sort of geospatially enabled to be analyzed. And we sort of categorize this into two types of data: spatial data and non-spatial data. And we're talking about in their native format. And so with spatial data, we have two standard formats: vector and raster. Vector is seen are point, lines, and polygons. If you look at any paper map or any digital map, you can pick out points, lines, and polygons, roads, waterways, schools, and boundaries. Pretty standard. The raster data gets into sort of a more interesting format. You have satellite imagery, but take a look, for example, at weather data. You have climate and weather stations that are located across, but in order to get that coverage of weather over the entire U.S., you can't sample every place. So you're using interpolation models to be able to better understand precipitation or the temperature between variables. And so that's all. Raster is sort of just a grid, a picture of data where each unique cell represents a value, whether that's elevation, weather, agricultural yields, and you can go back and forth between those two formats. Non-spatial data, tabular data, anything that you can find that you either see in a Microsoft Access book, a SQL Server database, anything that's tabular data, as long as it has a location, we can start to make that geospatial. Place names, XY data, so ship locations, water quality samples, demographic data, farm yields. Really anything that has a location to it, we can make that geospatial data and we can use that in a GIS system. So we make non-spatial data spatial by sort of more or less three common approaches. There's other ways as well, but by geocoding, so taking addresses and mapping that, you do that sort of all the time with Google Maps. This can now take the 4 million records of addresses and run that through and say, where are these addresses located across the state? How do I now compare that with the demographic data underneath? Mapping XY, latitude, longitude, and sort of joining existing geographic extents. So if I have knee replacement data for all of the US by sort of a hospital service area, how does that deal and how does that relate to sort of the average income? So we can take that from a non-spatial, relate it to a spatial, and then analyze that. So I think, and we won't have to go through all of this. So this is just, how many of you have used or seen geocoding before? So this is sort of stepping you through this is geocoding crime. You have a spreadsheet on your left that's going through and you have an address where the police have compiled their crimes. So this address happened, and I will say that this crime, there's a lot of data cleanup involved in this. So while this looks pretty straightforward, plug and play, there's data management, data cleanup, getting things in, and being able to move forward. But ultimately, you're taking the address field, plugging this in, opening up a geolocator, and being able to say, what fields match? What am I using to sort of geocode? And I have an address field that is the 800 block or 800 Main Street. And then it will run through and actually go say, okay, are you in the state of California or even the state of Massachusetts. And you can start to narrow those down in. And ultimately what happens is you can, if you have 4 million records, depending on what system you're using, wait a couple of days or find someone that has a system such as what sort of both of you guys are helping to set up, where I can say, hey, I have 4 million records. Can you help me do this in 2 days? And then ultimately let that output come and it will throw everything on the map. And now you're able to analyze those crimes. And so what this map is actually pulling up here in 2 seconds is going to be crime across San Diego. And I think it was between March and June of this past year. And so taking a look at that and understanding the relationship of crime across the county. That's not really, you can't really look at this information and say, oh, I understand this. But what you can start to do is filter out certain categories. And so we can take a look just in the charge. There's a whole list of them, but taking a look at, for example, identity theft. And so does identity theft, what other things are happening? Maybe you can take a look at bank robberies there, or what other factors might play a role in identity theft. So again, it's just querying the data that all started from a basic spreadsheet and mapping it out. And this is really just that entry level in, because we're just mapping the data. But now you can start to really pull that in and go to a different direction.
What's the program that they're using there?
This one would have been ArcMap. And we'll get into that here in a second. So it's using ArcMap, which is one of the desktop platforms that's available. And actually both of them are using, and this one doesn't want to pull through, but it was showing latitude, longitude of Starlink calls using ArcMap. I had a third one that was running into some issues using Pro. But I think we'll talk about that here.
Point though, like that is that the interaction that you're doing at that point was ArcMap or ArcGIS Pro, but those locator services, like they can be something that we're hosting ourselves. Esri provides some world map. Google actually does as well. Like a lot of services provide these. They're just generally at a cost, which is kind of what we're working on, is bringing that cost into, it's our compute costs, not our credit cost.
And the formatting for the data that you're receiving, I mean, you said there was a lot of data cleanup, but is there a lot of like that? I assume that has to go in a certain template to be imported into ArcMap. No.
Any sort of CSV text-based file, you can bring it in, and usually, I mean, John, and you familiar with as well, it's a data cleanup. So you get data in its raw format, and it's a matter of, I mean, that crime data, I had to clean it up because it was the 300 block of Main Street, and that was the entire list. And so you just go through and figure out, how do I eliminate block so I have that? So it's still, your mapping of data is only as good as the data that you get.
Right.
So,
Garbage in, garbage out.
Yep, and address data is notoriously, like, it has street abbreviations or extensions that will make those attribute mappings incorrect.
and so this as well as taking a look at malaria increasing rates from 2000 to 2015. And so the 2 maps on the right and the left are sort of just taking a look at malaria incidences. And then that central one is the change between 2000 and 2015, with your purple spots in the center map being areas of increase, with your green being sort of areas of decrease. So where do you direct your resources, right? If you have limited resources, you can now start to better manage and better utilize those. So the evolving role of GIS. And this is taking a look at the past. Data access meant let's bring in some maps, let's digitize them, let's generate that digital data that we can work from. So now it's sort of this concept of, let me just pull it down from the cloud somewhere, someone has access to it. Yes, there still are data huggers out there, and it depends on where you're working and what country, but it's this idea that data is more accessible, and it's just a matter of identifying and filtering through to find that.
And a lot of that data is actually made public by state agencies, city governments. Just another anecdote, like we brought in a visiting scholar from France recently. She's never touched GIS, but she's actually working with us in the foothills outside of our area. So she wanted to be able to produce a report that she can give back to the group that is actually sponsoring her to be here at Davis for 6 months. Without ever touching GIS, she was able to search within the Esri platform and find, this was data from, boundary data from Placer County, one of the water resource boards there, and one other state agency, and basically find the intersect of that without actually drawing out anything herself. And this was something that she did without needing to talk to anybody. She just went in and said, okay, I need this data. Here's the layers, that's where it is. It is really easily available for a lot of basic information.
I mean, in such an example is Living Atlas. Living Atlas is sort of a curated set of data sets through Esri that say, oh, you need some state boundaries, you need hydrography data sets, let's go out, census data, I can go out and access some of that. So some of that is freely public data, but it's in sort of that native spatial format that one needs to sort of get in right away. Another one is data.gov. And so data.gov is another sort of common sort of the US data site. You can search through a geospatial filter and start to see where I need to download it, can I actually pull it in as well. So both of those resources are great, and that's just the starting point to be able to talk about data, but more importantly, sort of in the modern GIS ecosystem.
So in talking about the modern GIS ecosystem, we are actually just going to throw out a disclaimer in there because a lot of our talk is about Esri, but the real focus of what we're talking about is finding the right tool for the right job. And a large portion of these tools are open source. And you can kind of see, I mean, this is a small representation of the community. It's not just Esri specific, but it's, again, it's finding really the right tool for the right job. And with the collection in that toolbox, you can really make some interesting outcomes.
So that said, we are talking about Esri here. This is the topic we're all around. So, and pretty much if you talk to any GIS professional, even if they're using those open source tools, if you ask them what they think about, what software they think about immediately when you talk about GIS, it is ArcGIS, but specifically ArcMap. But the point that we want to make here is that GIS has really moved beyond that desktop platform. So while there's still, I mean, they're releasing updates to ArcMap and they've launched ArcGIS Pro, it's moved beyond and it's moving into that software as a service realm. These are services that are provided either housed on campus or in your own institution or hosted in the cloud. These are things that you can go to without having to download and install anything. And that kind of leads us into this world of software as a service, but it's also distributed. So there's a lot of power there. As soon as you talk about scalability, we can spin up additional services on demand. We can launch these in AWS, or we can, again, house it in our data center. The geocoding thing that she showed, we can take that, like if we're talking about millions of records, like she said, we can go from days down to a couple hours by leveraging that distributed infrastructure. So kind of let's take a step back and talk about with that distributed computing, we need to look at what are the core components of GIS. And now it is beyond that just spatial infrastructure. It's about the content we're creating, and it's still about those analytics. But it's really about enabling that sharing and collaboration. That's what makes you be able to go to these state agencies or Living Atlas. And somebody provided that, like they built that data, but they're the ones making it available. And that's really the core enabling function of science.
And just to kind of harken back, I think before Google Apps was around or before really collaborative editing was around, how did we share documents then? It was like, make a copy, put it in an email, zip it to someone else. And not that didn't work, right? It was pretty effective for a while, but it really sort of capped your ability to share, right? It capped your ability to like turn these things around really quick. These portals, these functions, take that around and actually start to enable real-time collaboration and discovery. And that's a really powerful concept. A lot of the time what we're talking about in terms of like, we're looking at a geospatial cloud, right? So this is a service that's consumed, and it's actually vacuuming in new sets of data, integrating with different types of infrastructures to kind of enable new outcomes. And that's actually really exciting. And what we're sort of going to hone in on today, and a lot of our examples are what we refer to as the web GIS, right? So this is the portal that people are going to log into, and that you'll see is extended. So things like advanced visualizations or being able to drop some points on a map and geocode them very easily. These are all extended from the web GIS.
And so looking at, I mean, there's a variety of different platforms that can be used. Traditionally, when we talked about GIS, it was one specific platform. It's like, here's the software you need, here's the code you need to access it, and go. And now it really spans from field apps, business apps, design apps. So how are you designing urban environments? Viewers to be able to communicate your message out, not the editing tool that you're using, but rather the full story. The story maps and even dashboards. How do you take a look at location-based data, also with sort of charts and graphs that also sort of emphasize the data that you're dealing with. So it's a full suite. But when we're talking about this, the license that we're dealing with and sort of who are the users who have access to this software and these resources within our academic institutions. So we have the academic side and the planning and management and operations. And so between those, faculty, researchers, students, and then safety, security, facilities, planning, they all can leverage this. So safety, where incidents is occurring, where you need to either install a new blue light or a call space. The applications are endless, but we talk about this because there is sort of some approaches that the Esri license identifies in terms of use. If you're talking about open source, it really, you can use sort of the tools for anything. But we'll come back to that because there's sort of differences between the academics and the administrative planning, but ultimately everyone can have access.
We're going to see a couple examples of both, right? We're going to, Carlos is later going to talk a little bit about how at UC Davis they're using it on the planning and operations side in kind of a novel way, and I think we'll be able to explore it.
Yeah, but I think without this, there is, and Carlos, move it to the next one. All of this is sort of, there's this whole side support as well that enables these people. So in terms of the infrastructure that you have, in terms of whether it's individuals, whether it's support, enabling single sign-on. So I don't know, John, do you have single sign-on enabled here for campus?
We do.
Right? So, and it's things like this that say like, who did you use to get that single sign-on enabled?
The same person who does it for the all library databases in the central IT department. So I was able to ask our person who to contact, and it was just a few emails.
Yeah. So it's things like this, right? It's a larger network. It's not in sort of in the back. It was here's your software, go for it. You're on your own, and now it's really a team approach.
So now we're going to talk a little bit. She's mentioned that they're the Esri license, right? So trade secret that all the campuses actually do have some sort of site license. Like it's not managed exactly the same way, and there's different versions of it. But the point to say here is everybody should be able to have access in some way or another. So what is this? 9 of the 11 campuses, including A&R, are actually grouped together in what's called the consortium. I like that word. I'm just going to use that from now on for the consortium. But these are all the campuses that are involved in that group purchase. And you can see like there's slightly different levels of access, but the point that I want to make is look at these numbers at the top. The 2 of the smaller campuses are at 1,000. The majority of them have 5,000 named users. I'm going to tell you that none of the campuses are near that 5,000. So we're significantly underutilizing. And that license, that's not ArcMap. That's roughly everything that most users are going to use. That's ArcGIS, our ArcMap, ArcGIS Pro, and a myriad of online resources as well. These down here, I just found the laser on here. These are field apps. So these are things that you can actually send people out to the field and actually do that data collection, and it's all integrated. So I can send somebody out, and we'll actually see some examples of this further. We're talking when we're walking up, like where are the water fountains? Like you can send out a team with their mobile apps, or even do a citizen science type deal. Like send out a link. If you find a water fountain, go check if it's there. let us know, and that will show up on a map,
But-
all integrated.
And sort of like you as a user can actually generate that using this one of the apps, Survey 123, which is very similar to Google Forms, sort of this drag and drop. And the difference is it has location embedded within that form process. And that is one of the big differences. So you don't need to know anything about GIS. You have a list of questions and you want to know the location.
So let's just say you've had a fascination with hair ties.
Mm-hmm.
And walking around campus, of which there are plenty of old hair ties in the ground, you had your Survey 123 app, you could sort of use that, collect that data, and very
And then you could
easily,
make a map of where most of the hair ties were found?
you could do that
And
even
it would be
better. So-
live.
I mean, and I know from working with another educator, they
And
did
then you
one
can crowdsource it.
Yeah, they actually did sort of where are the best looking girls stationed on campus, right? And so like that is a perception, but it's a matter of like there are spatial patterns to that person's perception of.
So the Survey 123 doesn't require like, it's just like something you can send out and anybody could use it, and it's like using the locator in their phone?
Yeah.
Correct.
Really? So that's like get it done, San Diego, get it done?
Yeah.
Like
Yeah,
something like that.
I think in the back end.
Huh.
And for
So
certain
it's not-
applications,
that
like
ties
you
into
do
the
want
infrastructure.
more equipment than just that. But this is an excellent way to get started with any of this, like crowdsourcing.
Well, shoot, I just want to do it now for fun.
And even those,
Bingo.
that's not using those 5,000 licenses. Oh,
Really?
the license count is the people that created that.
So Survey 123 doesn't, that's not the license. I use the license because I created Survey 123, but the public would not be.
Correct.
Well, crap, let's do something.
So for example, we have you don't even need an app, you just go to a website, it will show you where you will locate you on campus, and if there's a problem with the bike path, you can take a picture of what the problem is, you know, there's a pothole, you know, somebody lost some traffic cones, snap a photo, attach it, and it goes off to the Associated Students Bicycle Committee.
We're going
And
to
they
see
respond to it.
we're going to see an example later of how this is actually used in curriculum at UCTech, which is really interesting.
I'm sure that's cool,
But
but
like with that example too, it's like activating so that it goes in and someone gets notified, like, hey, ding, there's an accident, and all of a sudden if there's 20 reports that come in, it's like, okay, we need to go send someone out today, not next week.
Since we're talking about licensing, just a little caveat that there are differences in the use cases. So like if this is, we're gonna say that that's research, right?
sure, I'm doing research.
We have like way more flexibility with the research licenses and like what products we have available, the counts of those involved. So the ability to access this stuff is still here for a lot of the administrative operations, but the limitations are lower. Like so, I think we looked at there was 5,000 for the academic use for most of those things. There's 100 in the administrative space.
Yeah.
And that's not to say we can't get more if that's what's included in the license, the consortium. Like, and I believe most of the education, John was just saying that most education licenses across the US are the same.
I'm not familiar with this administrative use part. Like, how do you track? How do other campuses track administrative users versus
So
others?
we actually, at Davis, I can't say for anybody else, but the call that I was on and the University of Michigan is doing the same thing. We have a separate organization for administration. So it's a limited set of people that we actually still use single sign-on, but we're filtering who can use that single sign-on.
Like right now, UC San Diego is everyone has access to the same agreement. And right now, I think we're still doing a cost recovery where 7 departments are buying in. And so campus planning is one of those, but now we have the health services side on. And the health services side is really interested in like where are patients and where do we need to cite a new hospital location based on the services side and where do they come from hospitals for. So like there's some things like that where it's more like to further the business.
And I have to say that this part's not been communicated very well because last week at the Desert UC, we were at the Education Summit, a lot of other universities, a lot of them were rather surprised, but it is actually documented.
It's in there, sure.
Yeah.
So that sort of brings us to sort of the web GIS enabled sharing. And we realized that we have the luxury of we're sitting in a computer lab today and we have an hour and a half. And so what we actually are going to have you do is just go out and sort of see some of these tools. So you get the next one. you go into an internet browser and type in arcgis.com or www.arcgis.com. What you are going to be pulling up is one piece of the platform, which is the online mapping tool, which sort of enables you to really, it's one piece of the platform. So I'm going to jump over here, and let's see if I don't mess things up here. So one of the things that I really leverage ArcGIS for is we've been talking about the desktop, this Pro and this ArcMap. Those are, if any of you are familiar with Photoshop or AutoCAD or that, they're sometimes tools that are very technical. And so ArcGIS Online is seen as a very low barrier to getting in and to mapping. So if you have, if a history professor comes to me and says, I just need to map out a few locations in Mexico for a publication, I'm not going to direct them to the desktop tools. I'm going to say, just go to ArcGIS Online. We can get some information. You can map your stuff and get going. So, like, where do you go? Do you sign in? Well, with the IT folks here that are setting this up, I can go sign in and log in with my credentials and go. But there's also this component that is free. So if you click on Map up above, we can actually get into this without even signing in. So there's still this level of public facing. Anyone can have access to it, but you're limited in your analysis. So great, I have a map. In my upper right-hand corner, I have something called Modify Map. That gives me sort of some data. I can start to search. So where are we? We are in Santa Barbara. Santa Barbara, California. I can bring that up. And I'm interested in the topography, but I'm actually really interested in sort of taking a look at the imagery. So I can search and change the base map, which is on my upper left-hand corner, and pull up some of these underlying base maps. And so these base maps are available for you to use and leverage and just get started with. So I'm just going to pull in the imagery hybrid if the streets at night are something of interest. I think that's actually a new one. We can start to explore information in greater detail. But I can still access and add data. So one of the things we were talking about is the living atlas. A map is just a satellite image, that's great to look at, but I already know where I live, and so I'm actually interested in taking a look at other data. This is where I can start to say, I can either search for layers, browse the living atlas. If I have an XY file that I've collected from a GPS unit, I can bring that in. You can go out and search the living atlas and search for anything you're interested in. I think I was looking at biodiversity, but you can also search for census or demographics, and just sort of play around for a minute or two and see what data sets you can find in the living atlas. So there's a few things. Make sure your living atlas, you're searching the living atlas, otherwise you won't get results. And you can start to scroll through and see what resources are there. And I will give you a hint. This is data, right? Who has the authority to sort of publish these data sets? You'll also see there's a field down below that's called who created that data set. And so if you're not sure on something, if I search, I can actually see who created it. I click on the link and it gives me more metadata about that feature. So just spend a few minutes sort of exploring the living atlas and see what data you can come up with.
That said, I forgot something very important in the Esri license part of this talk. While we all do have a site license, they're managed very differently across the campus. So UCSB, it sounds like that you guys provide open access to everybody.
Yep.
Non-cluster company. Great. So UC Davis is actually in that same boat as of last year. We've traditionally done a cost recovery, which is very expensive and time consuming. And really this site license is not very expensive. We're spending way more in FTE managing and providing access to that than we were like for the contract.
And another thing is, in addition to all these end user tools, like all of their server things are available.
Oh, yes, absolutely.
So we can build, commercial, global.
And we'll talk
class
about that a bit
spatial
later.
data.
Well, we have a whole section.
So I'm going to come around and just sort of see what you found anything.
We're going to check.
And you can pause your yeah. And I think what you
Yeah. Or yeah, you find like multinational organizations and
Yeah. So if I wanted to populate your group, and that's giving you.
I mean, it's my opinion. Whenever they update their data, some of that stuff is.
The fact that I'm.
Whether that tends to be pretty.
So,
But like, sometimes just here, like, somebody drops somebody down the street that's not gonna be there.
And so when you.
So actually, all of these are provided, they are best. Access, so that's kind of like what it is. Just consume HTTP.
Here are protected fisheries nearby, kind of around the islands on the coast. This is federal waters. And then the green spots are nearby sensitive habitats on the land. That's relevant. All this stuff is federal, so that's why it's on the same cover. And there's good, better, and best habitats up in the mountains nearby.
Yeah, so I mean, so it's a range of things, and the idea is like you have access to it, and so through each institution, one single sign-on enabled, you can just sort of log in automatically and have access to that. So at San Diego, we're still working on that.
I would be more impressed with what.
So I did a consultation with our institutional advancement folks that they had all of the applicants' zip codes the past 5 or 6 years. They were using it to plan recruiters, both recruiters' travel schedules. So what are high yield areas for recruiters to visit where they can go to all high schools and really get applicants. But they were also looking at the sociodemographic aspects because UCSB is starting to fundraise for becoming freshmen parents. So if you have incoming freshmen who's out of state who live in especially with zip codes, they get a nice special invitation for things like special campus tours and parents up in the for the kids.
So I understand that conceptually, that's awesome. I don't understand how to use this.
To get there, it takes a while. Yeah, there is a barrier to entry, but I worked with those folks for maybe an hour, 90 minutes, and then they went off and they wanted to do on that.
And they import their data.
Yeah, they came with a spreadsheet, and I attached, I helped them attach it to zip codes, and then showed them how to attach the other demographic information.
I think the tools are really easy to use after a short barrier.
There's a hump.
Yeah. Just getting your data to be spatial data like what we showed you, that's really your challenge. And after that, it's exploring.
Yeah, and then like seeing the path from idea what do you want to map to like having that finished product. That's a conceptual thing that takes a while for people to kind of.
I mean, it is. It's sort of get in and start to explore, and then if you have a question, figure out like what are the data sets that I need or what would help me answer that, and then you can start. I think the thing with GIS I found is it's never just one question. I don't just answer my question, I generate more questions based on the information that I found. So it's sort of trying to keep on path with all of that. So as we go through, one of the other things that I think I'm going to hold off for now, but you can explore later, is exploring sort of these story maps. Story maps is a way of communicating out some of the results. So you've done some of these analysis, John, like you've talked with the people, they've done their analysis, and how do we communicate that out in an internal way? So we've just pulled up a few story maps. You can go explore on your own time, but here's one that's taking a look at sort of real-time visualizations of wildfires across the US. So pulling in different data from NASA, NOAA, CAL FIRE, news reports. It's interactive. Don't forget the digital humanities. So how do we take a look at these information in these pieces of history to pull in? So looking at archaeology sites, whether they're on land or even underwater. And so the idea is story maps, I would say like go explore those at some point, but you can create these to share out. And the one final thing as well is ArcGIS Hub is a way that's bringing all of these together. You have a story, you have data, you have maps, you have information. You can combine this into this new environment, which is ArcGIS Hub, which enables you to communicate those results out to your constituents, whether it's someone else in the campus, whether it's someone else out in the community, or whether that's someone a student's been working with the community project. So ArcGIS Hub is actually really a really interesting one. So I guess quickly to talk about the evolution of GIS services within typically libraries. There's a variety of different models that are being supported across the UC system. It's providing access to data. It's supporting tool recommendations. So what tool do I need to do? Also workflow. How do I go from, I have this data set to map it to how do I run a geographically weighted regression on this to understand the correlation between the variables that I'm looking at. So a variety of different things, but the interesting aspect is there are individuals in every UC library that are supporting this at some level. So they can help navigate the different channels. And there's resources on finding data, tutorials, and all sorts of stuff. And I want to talk about sort of data access in the traditional model. And John, I actually pulled this from yours to be able to, yeah. And I say because yours is actually better than ours. We're still like directing people come into our lab, log into this network drive, find your data, because libraries have historical data sets. But with Santa Barbara and San Diego and Berkeley and UCLA and several others, we're transitioning to a new model that is a geospatial discovery platform where a user can log into an internet browser and search for wetlands in Santa Barbara or plant species around Davis, and I can pull up the file and interact with that and see the data before I actually start to work. So this is sort of transitioning those components out. So that's in the library, but in terms of the instructional setting, how do we actually get that data into users?
And so this is where we're going to try and say very simply with broad strokes, be like Google, right? For a lot of us, we have campus agreements for our Google suite, right, G Suite. We wouldn't try and license sheets, right, specifically, and then charge for it. And so that's kind of a tricky thing, but once we can kind of go beyond the cost recovery, we can sort of really start looking at this. How do we leverage it as an entire platform that enriches everything else, right? It's just there.
So yeah, I actually am going to follow up with that a little bit, but when we're talking about things like Google, we're talking about these tens, hundreds of $1,000s contracts. The important point in this is an order of magnitude cheaper than any of those things. So this is not something we should even remotely be dealing with provisioning access to. I think I only know within the consortium, the most any one campus is paying is $15,000 for their site license. So if you think about that, like, that's a fraction of a person's FTE.
6,600.
Yeah, and that's like, so 50,000 is the most. Why are we dealing with this? Oh, that's what really we should be dealing with is like providing the resources and actually doing GIS. So what UC Davis, similar to UCSB, is we actually got this fully funded committed for 2 years at this point. But what we're able to do is now provide on-demand access. That means nobody has to come to us and say, like she said, do I want Google Sheets? Who do I go to? They just go get it. So we have to do a really good job at providing relevant documentation, so knowledge-based articles. But really, we're providing open access to both ArcGIS, ArcGIS Desktop, ArcGIS Pro, and online. There are methods for people to get it without talking to anybody. So we launched this in early December, and basically I'm just going to talk a little bit about the change in usage by not having to go through those complicated processes. Prior to this, we were doing cost recovery, which meant we were selling 230 licenses a year. That was in 2018, we sold 230 licenses. What that really meant is that was split across 70 different departments. So at least 3 people are involved with all those transactions. Probably more than 70 different transactions, because we know how faculty work. There's one grant here that's going to fund this part of it. And like just a mess, right? So removing that cost barrier, we went from selling those 230 and providing 150 for lab environments. Since February, we had 500 unique connections for ArcGIS Desktop, that's the legacy software. That's what we're trying to move away from. But with less work, we're providing more access. So that's all about enabling, right? In addition to that, like almost nobody was using ArcGIS Pro because it was so complicated and nobody really knew how to deal with it, who to talk to. In our campus, it was actually, you talk to one person for ArcGIS Desktop, and you talk to a different person for ArcGIS Pro, and neither of them had access or insight into each other's usage. So opening that up, we went from having around like 35, 40, to we have 144 just ArcGIS Pro users. What I didn't put in there, or maybe I put, yeah, okay. So in addition to those 144 actually named users overall, so this is ArcGIS Online, which is the stuff that you just did, just signing in, which means that you can create content and you have access to analytics. And those mobile apps that we talked about to create those mobile apps, or sorry, to create the content for those mobile apps. We've moved from the same set of 40 people had access to all of that because that's online. We have 1,600 at this point. This is 8 months in after opening up access. So that's, I mean, it's order of magnitude, again, larger. And so the point that I wanted to make here is this is not only about the number of users. So like, yes, we can provision out tons of users. If nobody uses it, doesn't mean anything. So what we're seeing here is the beginning of December is when we opened up. Our peak usage is around 4,000 hours in a day. Is that okay? That's in a month. Okay, sorry. But that's huge, and that's without me talking to anybody other than sending out, it's now available to anybody. So I think that's huge. So we talked a little bit about like the wide use that this can have. We're actually using it a lot in outside. I mean, we're using it in research, we're using it in academics, instruction, but we're actually using it quite a bit in administration. So Michael mentioned before that our campus planning has been using this for years, and this is actually part of their workflow already. We're starting to work with facilities to enable ArcGIS indoors for like wayfinding and building management. But I wanted to include, we didn't actually do that. This is actually our grounds map. These are trees. So this is UC Davis's tree canopy. We actually took a service that we're already providing and categorized by color. But if you want to take a look at this link down here, it's actually got a ton of extra information. So we're doing tree records, maintenance records, diseases that we've seen in the past, and like things like broken limbs. And this is all actually used by our grounds crew on their mobile apps. They're using Collector, I think it's Collector, maybe Survey 123. So when they go out and work on something, they update that tree information. So we actually gave a demo of this that I don't have here, but if you can see emerging disease information in certain areas of the campus, so that you can start to identify this is going to be a problem. We're starting to use this for basically our climate change models are looking that Davis is going to be something like the southern Central Valley in about 50 years. So what trees are going to survive in that? And so how do we plan for keeping our tree canopy when maybe, I'm throwing out a number here, don't quote me on this, maybe 50% of these trees won't survive in 50 years. What can we do now to start that going? So I put that as a public map, so if you want to look around and see what kind of data is in there, it's interesting. But actually, this has a public-facing component as well. Like I created that public map for you guys, but we have this campus planning.ucdavis.edu/GIS. We've now exposed several of these kinds of maps, including our trees, but including like road conditions. I think all of our bike parking, like bike racks and all the different style and maintenance information, that's on here as well. And that's something that anybody can get to. It's a public-facing application.
Question.
Yeah.
I'm assuming the base map is like a Google Maps or?
No, it's actually, we created this base map. We worked with Esri, so this is hosted on Esri, but we created our own base map and provided it to Esri, updated theirs. This is not the same, I mean, even outside of UC Davis, it's not the same as the Google base maps.
Are you able to map things inside the buildings yet, or is it just more like outside?
Yes, so like that's actually some of their new products, and that's some of those are not included in our license, but the kind of emerging product for that is ArcGIS Indoors.
I think this is kind of cool for like lab usage. The student wants to know like
that is.
4 seats available or something in this lab.
I mean, even like the current format without even for GIS, you
Yeah,
could
for that
actually
kind of-
sort of georeference plans that you have and sort of identify, well, where are the labs on campus to be able to help direct students to those places. And so there's ways of doing that, and what the technology is enabling to make those processes even easier, rather than thinking through, say, 5 steps. It's now a matter of, oh, here's something that's directly meant for mapping indoor spaces, and being able to pull in sensors so that all of a sudden, an example they gave is that the temperature in this room is too cold, I can submit a report using the form, it goes and notifies someone else, and then they can verify using sensors, like, oh, yeah, that is colder, we need to raise the temperature, or things like that. So it's, I think, just recent, but, yeah.
So the section was instructional use. So we're actually going to talk a little bit about, this is not our data, this is University of Michigan, but University of Michigan's really built out their service. So they're actually tying in their logins to ArcGIS Online to their identity management. I took just a portion of this. This is their student usage. So they've tied back and aggregated the breadth of usage across all the student majors. And yes, we're still seeing like there are a few large chunks. Like this would be in my school, that'd be probably be my college. But the point being, I think, do you happen to remember like how many majors he said that are not included in this?
Very few.
Yeah, it was like under 10 that like they have no users from that major that have logged into the service. So like while there are primary disciplines that use this, it can be used everywhere. And the next is a little bit of an example. So at UC Davis, this is the plant biology class. And so really nothing to do with spatial specifically. But this plant biology class is really about identifying certain types of plants. I'm not sure there's much more behind, that's my involvement in it. But I think 4 years ago, Dr. Jeff Ben started, he's been doing this actually for quite a while, where he had paper maps. So they'd have to go out and like say, I found this plant and this is where it was. And this was really about them getting actually involved in seeing the things that they're studying, because we have this, at UC Davis, we have this great arboretum on campus, which has pretty much every tree that exists somewhere in California natively exists somewhere in this arboretum. And that's true for trees, but it's almost true for plants. Like it's amazing. Go there if you go to UC Davis. But he sent students out into the field with collector, and they went out and found in 1 quarter, I mean, we've been running this for several years now, over 5,000 unique plant records. So that's them taking that mobile phone out, saying, I'm here, I'm identifying this plant, and they get a little drop down. You see kind of around here, this is the type of plant I'm saying, and they take a picture, and all of that is uploaded and live to the faculty. It has their name, and then they assign those out to the students they spot check, I think 1 or 2 records for each student, and assign them a grade off. But the point after this is it got them, one, to explore the campus, which I mean students should be doing anyways, but our campus is really big, and surprisingly, nearly half of them had never been to the Arboretum. I mean, I'm telling you right off the bat, go to Davis, go to the Arboretum, that should be like number 1 or number 2 stop. And these are students that this is not an intro class. So, it is an intro class, sorry. But that they've never been to the Arboretum before. So the other part of this that is not in the slide is Dr. Ben is working on a paper which essentially says that he's seen a correlation between their involvement and then the amount of time that they spend actually out there, and then the number of plant records that they collected with their grade. So just getting them involved, I mean, that makes sense, right? Like people are more involved and more interactive, they're going to do better. But this is a great example of using GIS in a non-GIS related class.
Nice. So I hope you all are buckled in for a fast ride at the road ahead. Nobody gets motion sick here? No? I'm just checking, because we're going to be flying through some slides. So we have a really exciting future. There are actually quite a ton of slides. I'm serious. If you're motion sick, it's okay. Hang out at the back.
There she goes.
That's okay. So we're really talking about, when we talk about the road ahead, we're really talking about amongst all our campuses and amongst everywhere. We're talking about building capacity at the campus level. And what we're really doing there is we're trying to enable things like single sign-on. We're trying to integrate these spatial analysis things with existing tools. We're trying to build outreach communities to connect people. And that whole goal is to drive growth. I want to just take a step back and talk about the platform as a whole. So it's got a lot of different pieces, right? Like I think we might have referenced, we've already made some folks busy talking about some product names and app types. There are a lot, but you can kind of chunk it up into 4 major sections. There's like desktop apps, it's traditionally what we're really familiar with. There are sort of hosted services, either in the cloud by Esri or sort of in our own infrastructure like ArcGIS Enterprise. And they're apps that we kind of consume like on our devices. And then we have this really cool thing, which it spans the entire product suite of everything we just talked about as an API. And that will be able to leverage, especially for developers in the audience, some really interesting integrations. We're going to kind of blitz through some new things for Pro. Pro is really the premier desktop app. All of the new bleeding edge things, AI, machine learning, image recognition, text classification stuff, that's all coming out of Pro. And the really exciting news is if you take a look at the modern releases, Pro, these are like a couple clicks to get some really interesting work. Previously, these things took hours of labor or days of labor to prepare. Now the modern infrastructure, very easy to do. There are numerous advancements in visualization and really sort of integrating with the Python API to extend that even to R. So crosswalking sort of data science workflows into the product are now capable. This is kind of another interesting feature. So you have model builder for Python. So you can actually now take with Python integration, I should say. So you have Pro, you're doing some analysis, but you want to make it repeatable. You want to be able to share it. Well, there's 2 modes you can do that now. So one is visually with like the model. Here's my data, here's what I'm doing to it, here's my output layer. It even has history and some versioning behind it, which is really powerful. And you can share that with someone else. And my favorite feature, not really new, they sort of implemented it, took it back, and then implemented it because everyone was really mad at them, is the Python export. So now we can take that into Python and then share it in an even more extensible fashion. Geoanalytics, this is essentially a Spark system for big data on your desktop, fully parallelized for big data analysis. That's amazing. For data visualization, we're now looking at sort of being able to visualize really, really large data sets. We've got a space-time cube here. It's got spatial and temporal stuff. So it's not new to this particular release, but it's getting more and more easy to use. And your ability to predict patterns and temporal things happening in the data is really powerful. And it just looks really cool. So the data clock visualization, which you have here sort of on the right there. Okay, good. Sorry, I thought it was more slide. The data clock visualization kind of gives you now that temporal domain again, like when are the events happening? So what we have here is like a hail distribution. So you have your geographic distribution that you have on the map. But now this other little bit's kind of telling you when are these things happening? What times of the year? What times of the month? Heat maps are in calendar form, are yet another way we can apply this. This is all within the same product. So previously, you couldn't do a lot of these things easily. So now these are drag and drop functions over really large data sets. Locate XT is kind of a really interesting development. So you can take unstructured data. So earlier we talked about geocoding data and having to be really well structured or else sort of the output's kind of interesting. Locate XT can take unstructured data and try and mine spatial elements out of it. Big religious texts, old documents. It tries to sort of bridge that gap between AI, machine learning, and sort of that geospatial thing for geocoding. That's actually a really interesting development. Not only just sort of textual, but we have sort of, they make drone imagery collection suites. So Drone to Map is a product that they make. It's an additional component, but now we can sort of take those things and overlay those as scene layers on top of our analysis to give it some more depth. Pix4D is a commercial product. Its engine actually powers the other one I just showed you. But what's interesting about this is they provide a whole suite to make drone imagery accessible. Essentially, you can take almost any sensor platform that you can have JPEG or a TIFF output or whatever other crazy sensor you got, and now you can make some really interesting captures from that. The output is amazing. So a lot of these outputs that you see on the screen, fairly complicated 3D outputs, you can now bring those in downstream and integrate those with other Esri products. We're used to usually thinking of like remote sensing from really, really high up. I want to talk about a quick example from the Pix4D website. This is actually mapping a vent 3,000 feet beneath the seafloor. right? Or before not the seafloor, or the surface of the ocean. That would be really far. That'd be like 6,000 feet. But they actually did this. They actually had a ground sampling distance of 2.7 millimeters. That means the resolution of their imagery, they could identify something at 2.7 millimeters, right? They did this, and the output of this, they actually counted almost 26,000 unique organisms at this event. They then took that, made a machine learning model out of it, and learned to classify the ecosystems and the ecology around them. That's kind of cool. So coming back out to the 1,000 feet, we were just at the seafloor. By my mistake, 3,000 feet beneath the seafloor. We're going to talk about ArcGIS Enterprise and what that enables us to do within our infrastructures, right? So we talked about Pro, we talked about the desktop app, we talked about ArcGIS Online and what that enables. Enterprise is something sort of near and dear to my heart because it allows us to take that and really extend it into specialized functions. So it has all the normal stuff. You can still share web maps, you can still consume it on a mobile device, you can still sort of have some server computation, but it's modular. And it's modular in such a way that the portal deploy and the server, you can actually start scaling those horizontally and adding bits and pieces in where you need that specialty expertise. So for enterprise, that really means adding additional server roles. And these are specific to the type of work you want to do, and really for the community for which they need to do it. So for our remote sensing crowd, typically they're going to be really interested in GIS Server Advanced and probably Image Server. That's going to provide a lot of that raster and multivariate satellite imagery analysis. So not only does it store the raster like in that imagery, but it allows you to run some really interesting computation. We'll see that in just a sec. So our geoanalytics provides super big data analysis over those temporal domains. That's really important. And things like business analysts sort of start to ask these questions and connect this data in different domains, different contexts. The little present down there is kind of an ode. So when we had this slide, notebook server for Jupyter notebooks and Python notebooks hadn't quite yet been released, but it has now. And so we'll kind of see an example of that and the exciting possibilities that opens up for. So here's an example of the image server, right? So we said it can collect raster image maps. So we basically can shove a bunch of data in there, collect it, aggregate it, build a model, and then make something like a solar plant sustainability raster to answer like, so is this a good idea to build a solar plant over here, or are we going to have like 90% cloud cover for the duration of the year? That's actually kind of a complicated computational question. This is big data, right? And so you can do it in local infrastructure. In fact, you can do it on your desktop. It may take you a couple weeks. But you can scale something from what's half a day down to really like 10 minutes. And that's the point here. So we can take that aggregation layer at the enterprise level with server, scale it horizontally in something like AWS, and enable, we can shift that day to minutes. Geoanalytics, that same concept of that scaling applies, but we can start aggregating big data sets and even looking at how they're connected and visualizing those in deeper ways, in ways that sort of our other data sets like raster imagery might not be able to provide. Notebook server, this is actually really cool. So we have hosted Python notebooks in the product that are spatially integrated with that API. So that's a really key differentiator, right? So it's not just another Python notebook. It's a Python notebook that talks to the rest of your infrastructure. That's really exciting. What that enables is it enables all those sort of interesting spatial temporal analysis, that geospatial data science in those notebooks. And that's something that people had to do a lot of work before to kind of actually do. And so here's an example. We'll try and not crash the presentations. So you could check this out too. Check out the ArcGIS API for Python. They have a bunch of samples. We're just going to kind of show this one to you here. And quick show of hands, anyone familiar with like Python notebooks or Jupyter notebooks? A little bit, okay. So essentially, we have what looks kind of like an IDE. It's kind of not, right? But you can put actual code in it. It's run real time. It's connecting back and actually giving you those results. But it's actually kind of mixed mode. It's letting me document, tell a narrative, and actually start to pull in this case, geospatial features. That's Landsat imagery in like 5 lines of code, specifying which band and whatever else you like. In this next example, we're actually starting to tap into an NVDI layer for that and pulling out vegetation indexes. Down below, we're using scikit image to actually then classify that and see what happens when we've actually got farm detection. And down at the bottom, we have our output, trained model, and we've actually detected about 1,000 farms. So this is really, really important. Like this specific example is just the tiny fraction of what sort of the spatial integration can enable when you talk about it. Anyone else excited about that? I'm super excited about that. Okay. And so I really want to, so that bridge is we're really sort of talking about that sort of API, right? And how rich that is. Here's a really interesting example. So Esri and Microsoft and UC San Diego taught a joint course. And it was really around, in our Data Science Institute, asking the question, could we take data science students with very little geospatial background and sort of introduce these concepts and then see how far we can push them. And the answer, the course was taught by Dr. Zavlosky from San Diego Supercomputer Center and Dmitry Kudnov from Esri. The answer was really far, like graduate level far in 10 weeks. That was sort of how some of the external input was reflected on that class. That's actually really cool. So we just said they had 0 geospatial experience, right? They learned some geo, applied their data science curriculum to it, and the output at the end of this, one of the submissions, they actually trained machine learning models for image classification and using a single multi-shot detector. And they're actually now using Pro to pull in and classify imagery. In 10 weeks, that's an amazing feat. So if we come back out to that 1,000 foot again, to take a look at those apps and those endpoint applications, they make a lot. We saw, I don't know, we talked about at least 5 or 6 today. They make a lot more, okay? In fact, what you see on the screen right now is just the tip of the iceberg. And that's all kind of being enabled by Esri themselves developing new applications, but also by local applications in the community. And it's not really hard to get started. They actually have some fantastic sort of quick builders. And so if you're interested in trying to apply a geospatial concept and you're a developer, I would highly recommend you take a look. So kind of putting this all together, we talked about NatureServe a little bit earlier and kind of the importance of a model like that for biodiversity. But I kind of wanted to highlight how that comes together at the end. So we have NatureServe that has a machine learning platform, which is an incredible machine learning algorithm, spatial data science. We have that overlaid with historical classifications of where a species is thought to occur. We have some sort of decision-making things in terms of land use, what zone for what we can build. And what's important about this particular slide is you see there's like little dots on there called out in blue. So those are actual sightings of someone that was in the field with like a Survey 123 app and said, I saw one. And what this platform provides is it provides us a way to look at all these lenses and kind of ask, hey, that data science model is awesome, but it's only like 99% accurate. And where's the overlap between all the other facets and my real world observed use? Maybe you're trying to protect salamanders, maybe you're trying to look at endangered species. But the point is that platform, that converged platform, lets you answer some of these questions in really intelligent ways. So we're going to put it all together. We've got a lot of data out there, right? I work in a library. I love data. Like it's in the bones. But I think it's really important to kind of draw the conclusion that it's not just born digital, right? We have archives of amazing data. And it's kind of our jobs to kind of think about this. How can we enable our library collections, our literature, our historical printed maps? How can we sort of geo-enable them, right? How can we kind of fuse this ocean of data through the tools that we just talked about? Our focus, at least my focus on campus, is trying to maintain that conversation about how do we build that spatial data infrastructure? But that's all in support of the discovery and sharing. And at the end of that, it's really what we're after is we're trying to propel sort of novel research and learning outcomes for students and faculty and staff. Like that's the culmination of all that. And so who are you going to innovate with? This is not a single team. This is not a single department. It is for sure not a single person. But you have campus communities, right? You have your educational technology departments. You have your libraries. You have your HPC centers. But who else, right? Like who else are you going to pull in and partner with? Do you have institutes? Do you have special research grants that you might You have other academic partners who could make this a more rich experience. The idea here is it's going to take all of these to converge on what that geospatial platform can offer. This year at the Esri UC, one of their taglines was "See what others can't," and this struck a chord with me. So as they're developing our data science curriculum for our undergraduates, the focus is on solving problems. Absolutely, the focus is algorithmic and it's exactness. But there's this larger contextual focus, which is learning how to ask great questions and depth of questions. Like, it's not just making a model, but it's asking, is there bias in my data in the model which I'm trying to answer, how I would geographically model school districts and the output of that. And that's that culmination. I think the culmination is that's the output. So we're really passionate about Esri and about all these open source tools, about tools on how we enable that end goal. So I'm sure a lot of you are asking, what can I do now? Because that was a lot of apps, a lot of product names, a lot of maps.
So yeah, this is where you guys can get involved, right? We've been, this presentation was our first real collaboration. Michael and I happened to sit next to each other last UCCSC, and we just happened to be talking about, oh, what do we each do? We both work on GIS. So that's how this kind of collaboration got started. Michael introduced me to Amy. We're really trying for some type of system-wide coordination. We managed to do a pretty good, in my opinion, pretty good job at the Esri UC this year. And that was really last minute, to be honest. But we had we emailed about anybody that we could figure out was from the UC at the Esri UC. And we had a little over 20 people that were from the UC. I want to say that most of the campuses were represented in some sort, but we actually haven't really looked at who all was there. But these are, the point being that this is a collaborative effort that we're trying to accomplish. There are already communities around. Everybody should already know the UCTech Slack channel or Slack workspace. But if you haven't found these specific channels with it, there is an Esri specific channel, which is largely around organizing the Esri platform across the campuses. So that has to do a lot with licensing, but even just like product announcements and like how does, let's have some specific talk about how does this work within the Esri platform. If you're much more interested in the science side of this, so GIS as a tool, take a look at that GIS and mapping. But in addition, most of the campus has some type of geospatial community. So look at your own Slack, look at your own email lists. I'm sure that it exists. And if it doesn't, start it. There is an additional Slack workspace called the spatial community, which is much larger than just the UC. It's pretty much any topic that you can possibly think about. It has a spatial element. There's a channel that is specifically there for the spatial community. We started University of Cal, and the idea behind this is that we can get GIS professionals from all over the campus, not just our type of work, but actual people doing the research. Get them to communicate, get them to collaborate, because we're in the same system and we should be sharing resources. So yeah, there are local user groups, like I said, listservs, Slacks, but like we have map time at UC Davis, which is run the library, data carpentry. But the big thing is we're trying to organize, at least for the leadership roles involved, anybody that's working on something that may span multiple departments or leadership or span across the campus, we're going to organize a quarterly call just for us to check in. Like, we want those people connected, the facilities managers that are working with GIS. They should be talking to the other facilities managers at the other campus, see what we're doing and what hurdles we're seeing. Like, let's coordinate. Finally, there is like GeoNet. If you already do Esri, then you probably know GeoNet. It's a ask any question, you'll get an answer. And a lot of the time, you'll get answers from Esri. They're really good about keeping up with their products and their community. And if you're getting started, included in those licenses are access to training materials. We have learn.arcgis.com, and I think there's also training.arcgis.com. These are step-by-step with real-world applications, like starting with these are the data sets that we're giving you. Here's how to run through, and like here's, I mean, even starting out, here's how to geocode something. But those Jupyter notebooks, those are lessons within the learn.arcgis.com. So really, you can get started from any level, and there are resources for you.
Yeah. And I just want to add, if you just have interest, and you're like, this is something interesting, don't be afraid to participate. So geospatial data science as a field, as a community, requires the very things that I think we all hold dear to our hearts, right? Inclusion, diversity, not only of people, but of thought and approach. So if it sounds interesting, from whatever angle you are thinking about, come join the conversation. And if you don't know where to start, you can always reach out to us, and we're happy to point you in the right direction and get you connected with a lot of people.
Well, actually, if you flip to the next slide, that actually shows sort of why campus, who the contacts are, as well as sort of people that are in the library, but it also makes me think, as we pull this together, there also needs to be an additional column. So who's in planning, who's in security, so like this is really not just a single campus, but we have the ability to have a license for shared sort of agreement, and Barbara is within that regardless of like how that's arranged, but how do we communicate and how do we connect those people to enable this sort of in a timely manner.
And that is a conversation we got started through that meeting at Israel UC. Like we should be finding our counterparts across the campuses and working collaboratively.
We invite you to do the same.
So I think on that, there's those resources that will be changing. We talked about putting up a Google Drive, collaborate and continue to check so anyone can check in. But I think it's also like in sort of preparing for this, there are a number of people together.
The list is long. These are some folks that have stood out over the period of our trying to prepare this presentation, but that have been instrumental in what we're doing.
And we've seen a number of names that are across the campuses already, but Esri, like these people, it's not just like, oh, I talked to them by email. These people interact with us and they take feedback. We had a change advisory board last week where not just our campuses, but the greater education community were able to take our top 3 concerns and basically say, these are the things that are not working for us in your platform. These are what we need to see changed. And their education team, I think that was largely run by Peter and Jerry. They actually take those in, and we've already seen, I mean, not from our last week's conversation, but we've already seen changes that were driven by higher education. Higher education is around 50% of their user base. Like, we're only a fraction of their income, but we have a say, we have a voice. Oh, that's it. Any questions? I know that was long.
And you mentioned there's a lot of licensing, so I would just be too sheet to find out if I can.
You need to email me or Mary.
Luckily, we're at UC San Diego, so you should.
I know Meredith, so could I just talk to her directly?
Yeah.
And she would, awesome.
Thank you.
Thank you.